tonight, somewhere beneath the place where you are lying, there is a darkness older than any forest, older than any sea you have ever seen. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. That darkness has its own rooms and hallways. It has rivers that have never seen the sun. It has chambers wide enough to hold cathedrals and tiny cracks barely wider than a hand. And much of it has never been touched, mapped, or even named. Picture the surface of our planet from a calm distance. You can see the soft greens of forests, the wrinkled brown of mountains, the slow blue of oceans. The land looks solid. It looks finished. But the crust beneath our feet is not solid at all. It is riddled with hollows. It is laced with tunnels. In some places, the rock is so full of empty space that it hums like a stone flute when the wind moves through it. We tend to think of Earth as a place we know. We have walked across its deserts. We have sailed its seas. We have flown above its clouds. Yet, under all of that, beneath the soil and the roots and the bedrock, there is a second world, a quieter one, a slower one, a world made of stone and water and patience. No one knows how big this hidden world really is. That is the first soft mystery we will sit with tonight. Geologists have mapped many famous caves. They have surveyed long limestone systems in Kentucky, in Vietnam, in Mexico, in the wet hills of southern China. They have measured chambers so vast that whole villages could fit inside them. But every careful survey ends the same way, with a passage that narrows, with a tunnel that drops into water, with a crack in the wall that no one has ever followed. One common estimate suggests that we may have explored only a small fraction of the caves that actually exist. Some researchers wonder if it is less than 10%. Others think it could be far less than that. The truth is, we cannot say. To count caves, you have to find them, and most of them have no door, no entrance, no opening to the upper world at all. They are sealed inside the rock like bubbles in dark glass. There is something gentle about that thought. Beneath the streets you have walked, beneath the meadows of your childhood, beneath the cold floors of ancient seas, there may be rooms, no, eye has ever entered. Slow water drips in them right now. Tiny crystals grow on their ceilings, one molecule at a time. Pale creatures, if any live there, drift in pools that have not rippled in 1,000 years. The shapes of these underground worlds vary in ways that still surprise scientists. Some are carved by acid water nibbling at limestone. Some are tunnels left by old rivers of lava. Some are pockets melted into the heart of glaciers. Some are sea caves where the tide breathes in and out twice a day. Each kind has its own rules. Each kind hides its own questions, and the questions are real. How far do these systems reach? Do some of them connect across whole regions, joining rivers we thought were separate? How old are the deepest chambers? What lives in the absolute black, where no plant has ever grown? Could there be life that depends on no sunlight at all, anywhere in the chain of its food? These are not idle wonderings. They are open puzzles that careful scientists work on right now, with ropes and lights and patient measurements. Tonight we will wander slowly through this hidden world. We will follow a drop of rainwater as it sinks through soil and finds a crack in the limestone. We will sit in the dark while a stalactite grows by the width of a single hair across 100 years. We will hear about painted walls in chambers that humans last entered before the last ice age ended. We will visit caves of crystal, caves of ice, caves where rivers vanish without a trace. You do not need to remember any of it. You do not need to follow every turn. The hidden world below has been there for millions of years. It will be there in the morning. For now, let your breathing slow. Let your shoulders soften, and let your mind drift gently toward all that quiet stone and all the questions still folded inside it, waiting in the dark. To understand the mystery of caves, we must first understand the water that makes them. And the water that makes caves is not quite ordinary water. When a raindrop falls from the sky, it passes through the air and picks up a tiny amount of a gas called carbon dioxide. This gas is the same gas we breathe out, the same gas that puts the bubbles in soda. When carbon dioxide meets water, the two combine to form a very weak acid, not a strong acid, Not anything that would hurt your skin, just a soft, gentle acid, barely sour at all. This soft acid is the chisel that carves the underground world. The raindrop, now slightly acidic, soaks into the soil. As it sinks deeper, it picks up even more carbon dioxide from rotting leaves and roots. By the time it reaches the bedrock below, it is hungry, and what it is hungry for is limestone. Limestone is a soft, pale stone made mostly from the crushed shells of ancient sea creatures. Long ago, when shallow seas covered much of the land, tiny shells and skeletons settled to the bottom in countless layers. Over millions of years, those layers pressed together into stone. So, in a strange way, limestone is the graveyard of an old ocean. When the acid water touches this stone, the stone slowly dissolves. Not quickly, not even at a pace you could see in a lifetime. A single drop might carry away only a few molecules of rock, but water is patient. Water is endlessly, quietly patient. Think about it this way. If you watched a limestone wall for an entire human life, you would see almost no change. If you watched it for 1,000 years, you might see a faint hollow forming. If you watched it for 100,000 years, a small tunnel might open. And if you watched it for 1,000,000 years, you might see a cathedral. Most of the great cave systems on Earth are between 1 million and 10 million years old. Some are older still. The caves of southern China, with their vast green river chambers, are thought to have begun forming when our distant ancestors were still small creatures in the trees. The Mammoth Cave system in Kentucky, the longest known cave on Earth, contains more than 400 miles of mapped passages. That is roughly the driving distance from New York City to Cleveland. All of it twisting through stone in the dark. And cavers believe hundreds more miles remain unmapped, waiting in the silence. The chemistry is simple to describe. Acid plus limestone equals dissolved stone, which water then carries away. But the shapes this simple chemistry produces are anything but simple. A cave can be a narrow crack you must squeeze through sideways. It can be a chamber larger than a stadium. It can be a smooth, round tube that looks almost machine-made. It can be a maze of branching corridors that loop back on themselves in ways no map can fully capture. And here the first quiet mystery begins. We understand the chemistry. We understand the patience of water, but we still cannot fully predict the shape a cave will take. Two limestone hills, sitting side by side, formed in the same era, soaked by the same rain, can produce wildly different cave systems beneath them. One may hold a single vast room. The other may hold a tangle of thin passages. Why one and not the other? No one can say with full confidence. Some researchers point to tiny cracks in the original stone. Others wonder about the angle of the water table, or the slow rise and fall of the land over millions of years. The honest answer is that the deep architecture of caves remains, in many places, an open question. The rock itself helps decide. Limestone is the most common cave-forming stone, but caves also form in gypsum, in marble, in dolomite, in salt. Each of these stones dissolves at its own pace and produces its own kind of hollow. Salt caves can form in just a few thousand years, which by cave standards is the blink of an eye. Marble caves, harder and slower, can take tens of millions of years to open. So when you stand at the mouth of a cave, you are standing at the end of an enormous, invisible process. Rain that fell long before any human had a name. Stone laid down by creatures that lived before the dinosaurs. A slow, soft acid eating away in the dark, drop by drop, century by century, building rooms no one was meant to see. And much of what lies beyond that mouth, even now, has never been touched by light. Inside a quiet cave, far from any sunlight, something is being born. It is being born so slowly that a single human life is far too short to watch it happen. Drop by drop, mineral by mineral, the cave is growing its own strange forest of stone. These are the stalactites that hang from the ceiling and the stalagmites that rise from the floor. To understand where they come from, we have to go back to the beginning. The story begins with rain. Rain falls onto soil, and as it soaks through the dirt, it picks up a small amount of carbon dioxide from the roots of plants. This makes the water slightly acidic, almost too gentle to taste. That faint acid is the carving tool. It travels down through cracks in the limestone above the cave, slowly eating away at the stone as it goes. By the time it reaches the cave ceiling, it carries dissolved minerals with it, especially something called calcium bicarbonate. When that drop finally appears at the ceiling, hanging in the still cave air, something quiet happens. A tiny bit of carbon dioxide escapes from the water back into the cave. The water can no longer hold all of its dissolved minerals. A speck of calcium carbonate, the same material that makes up seashells and chalk, settles out and clings to the stone. The drop falls. Another drop forms. Another speck stays behind. That is the entire secret. Stalactites are nothing more than a slow record of falling water. The growth rate is almost too slow to picture. In many caves, a stalactite gains about 1/10 of a millimeter each year. That is thinner than a sheet of paper. A finger-length stalactite may already be 1,000 years old. A long, slender one reaching down from a high ceiling may have been forming since long before any city stood on the surface above it. Some are older than written language. Some may be older than the human voice itself. Stalagmites grow in the same patient way, but they grow from the floor up. When a drop falls and splashes on the stone below, it leaves behind its own tiny ring of calcium carbonate. Drop after drop builds a small mound. The mound becomes a stub. The stub becomes a finger of stone, then a column, then a thick tower with a rounded top. Stalagmites tend to be wider and stubbier than stalactites because the falling water spreads out when it lands. Sometimes, after thousands or millions of years, a stalactite and the stalagmite directly beneath it finally meet in the middle. They fuse into a single pillar that runs from floor to ceiling. These are called columns. A cave full of columns can feel like the ruins of an ancient temple, though no hand ever built it. The only architect was water, and the only schedule was deep time. The exact conditions have to be right for any of this to happen. The cave must be old enough and stable enough. The rock above must be the right kind, usually limestone or dolomite, full of the minerals the water needs to carry. The air inside the cave must be still and humid. The temperature must stay fairly constant. Even a small change in the surface climate above can change the chemistry of the drip below. If the cave dries out, growth stops. If the cave floods, old formations can dissolve back into the water that made them. Researchers still wonder about the finer details. Why do some caves grow long, thin, hollow tubes called soda straws, while others grow thick, ribbed shapes that curl sideways against gravity? Those sideways shapes, sometimes called halictites, twist in directions that simple dripping cannot easily explain. One idea is that tiny capillary forces inside the stone pull water in unexpected paths. Another is that air currents in the cave nudge the growing tip. The honest answer is that no single theory fully accounts for every shape we find. What we do know is that each formation is, in a way, a kind of slow recording. The minerals trapped inside a stalagmite hold faint chemical signatures of the rain that built it. Layer by layer, year by year, scientists have learned to read those layers a little, the way you might read the rings of a tree. They can sometimes tell which centuries were wet and which were dry, long before anyone was alive to write it down. So the cave is not empty, and it is not still. It is a quiet workshop, building shapes from falling water and patient time. And much of what shapes those shapes, we still do not fully understand. Somewhere in a quiet forest, a river runs along the surface in the usual way. It tumbles over mossy stones. It carries fallen leaves. Birds drink at its edges. Then, without warning, the river slows, gathers in a strange pool, and slips downward into a hole in the rock. It vanishes. The forest above it grows still, and the river is gone. These vanishing rivers are called sinking streams. They happen most often where the ground is made of limestone, that pale gray rock formed from the shells of ancient sea creatures, pressed together over millions of years. Limestone is gentle stone. Slightly acidic rainwater can eat into it, drop by drop, year by year, over long stretches of time. The water hollows out passages beneath the surface. When a river finds one of these openings, it pours in and keeps flowing in the dark. The water inside these underground rivers carries the same simple ingredients that fill every river on Earth. Mostly, it is hydrogen and oxygen, bound together as the small, gentle molecule we call water. Researchers still wonder where all of this water first came from. One idea is that the young Earth held some water in its rocks from the beginning. Another idea is that icy comets and wet asteroids delivered much of it long ago, falling in slow rains across millions of years. The question remains open. The river slipping into the cave may be moving through stone made of ancient seabeds, carrying water that may once have ridden through the dark on a frozen comet. Inside the limestone, the water picks up tiny amounts of calcium and carbonate dissolved from the rock itself. It carries traces of magnesium, of iron, of silica. Each grain of mineral was once part of something else. The calcium in the water was, long ago, locked inside the shell of a small sea creature. That creature drew its calcium from seawater, and the seawater drew it from older rocks, weathered down by older rains. Every drop in a sinking stream is a small museum of the planet's past. The journey of these vanishing rivers can be very long. Some sinking streams travel for miles beneath the hills, twisting through chambers no human eye has ever seen. They may rejoin the surface as a clear spring at the base of a cliff. They may run beneath farms and towns without anyone above ever knowing. To find out where a sinking stream ends up, researchers sometimes pour a harmless dye into the water and wait. Days later, the dye appears in a spring far away, sometimes in a valley over the next ridge. The path between is often a mystery. The water knows the route. The people only see the entrance and the exit. There are places where a single river drops into the earth, splits into many threads inside the stone, and emerges in 2 or 3 or 4 different springs, scattered across the countryside. How the water chooses its paths is not fully understood. Some passages are wide and easy. Some are narrow cracks the width of a finger. The river takes them all at once, the way roots spread through soil. The rocks that allow this to happen carry their own deep history. The limestone of these regions, formed under warm shallow, seas hundreds of millions of years ago. Tiny creatures lived and died and settled to the bottom in soft white drifts. Pressure turned the drifts to stone. Then the seas dried, the land rose, and the rock was lifted into hills. Rain began to fall on it. The slow carving started. Every cave river is moving through the buried memory of an ocean. Even the air that flows along with these hidden rivers has its own story. It holds nitrogen, oxygen, a little argon, traces of carbon dioxide. The nitrogen was breathed out by ancient volcanoes. The oxygen was built up over billions of years by simple living things in long vanished seas. The river runs through this old air in the dark, never seeing the sun. What is it really made of? This vanishing water in its vanishing channel. It is rain and shell and seabed. It is comet ice and volcano breath and the slow patience of stone. It carries the same elements that build the trees on the surface, the bones of every animal, the salt of every ocean. The river slipping into the hill is not separate from the world above. It is the world above, taking a different road for a while, and no one knows, in any complete way, where most of these underground rivers go. The map of them is still being drawn. The water keeps moving in the dark, carrying its old, quiet ingredients toward a place that has not yet been named. Far below the surface, in chambers where light has never reached, a quiet living world goes about its slow business. The creatures here have shaped themselves over countless generations to fit a place most life on Earth could never survive. They are pale, often nearly transparent, with skin so thin you can sometimes see the soft pulse of organs beneath. Many have no eyes at all. Some have only the faint memory of eyes, hidden under a thin layer of skin, like a door that has been bricked over and forgotten. The forces that shaped these animals are not the ones we usually think of. There is no sun here, no day, no night, no warm wind, no cold snap. The temperature in a deep cave stays nearly the same all year, often just a few degrees above freezing or a little cooler than a spring afternoon. The air is still. The water drips at the same slow pace it has dripped for centuries. In this changeless place, the great sculptor is not light or weather. It is time itself, and the steady pressure of having almost nothing to eat. Hunger is the quiet hand that shapes a cave creature. With so little food drifting down from the surface, every bite of energy matters. So bodies grow smaller, hearts beat slower, movement becomes careful and unhurried. A blind cave fish may live many times longer than its cousin in a sunlit stream. Some cave salamanders, pale and slender as ribbons, are thought to live more than 100 years, barely moving, barely eating, barely aging. One species, the ohm, found in the limestone caves of southern Europe, can survive 10 years without a single meal. How it does this is still not fully understood. Darkness itself is a force. Without light, eyes are a costly luxury. They take energy to grow and energy to maintain, and they are easily injured. Over many generations, in animals that never see the sun, eyes slowly fade. Some researchers believe this happens because the genes that build eyes drift and break without being corrected by natural selection. Others wonder if losing eyes is actually helpful, freeing up energy for other senses. The question is still open. What is clear is that in the deep cave, sight gives way to touch, smell, and the soft reading of water currents along the skin. In place of eyes, other senses bloom. Long feelers reach out into the dark. Tiny hairs along the body sense the faintest stir in the water. Some cave fish can feel the shape of a pebble several body lengths away, just by reading the way the water flows around it. Cave crickets grow antennae longer than their own bodies, sweeping the air like patient fingers. The pressure of having to find food in the dark has rebuilt these animals from the inside out. Color, too, fades in the cave. On the surface, color helps animals hide, attract mates, or warn off enemies. None of that matters in a place where no one can see. So the pigment in their skin slowly disappears, generation by generation, until many cave animals look almost white or pink with the blush of blood vessels showing through. Some are so pale they seem to glow faintly in the beam of a passing headlamp. The forces here are not violent. There is no crashing surf, no driving wind, no scorching sun. The pressures are gentle and steady, applied across vast stretches of time. 1,000,000 years of darkness, 10 million years of cold, still water, 100 million years of the same slow drip from the same slow ceiling. Under such patient conditions, evolution does not rush. It whittles. It softens. It rounds away the parts no longer needed and quietly sharpens the parts that are. What remains unknown is how many of these pale creatures still wait in caves we have never entered. New cave species are found almost every year. Tiny shrimp in flooded passages, strange beetles in cracks no human hand can reach, worms that may have lived in isolation for so long that they share no close relatives anywhere on the surface. Some researchers think we have found only a small fraction of the life that exists in the deep limestone of the world. Others suspect entire underground ecosystems remain sealed off, connected to nothing we know. So the question lingers. In the patient darkness, in the still water, in chambers no light has ever touched, what other shapes has life quietly taken? We do not know. The forces that made them are gentle and slow, and they have been working far longer than we have been watching. For tonight, it is enough to picture them down there, breathing softly, drifting through cool water, in no hurry at all. Deep inside a quiet limestone cavern, water has been busy for a very long time. It drips, it pools, it trickles down sloped walls. And in doing this slow, patient work, it leaves behind shapes that almost do not seem real. Tonight, let us sit with the strange scale of these shapes. How small, how slow, how delicate, how vast. Begin with the cave pearl. A cave pearl is a small, round stone that grows in a shallow pool, polished smooth by dripping water turning it over and over for centuries. Most are the size of a pea. Some are the size of a marble. A few rare ones grow as large as a tennis ball. To make one cave pearl the size of a pea, water may need to drip in the same place for 10,000 years. Picture that. 10,000 years of patient, steady drops, each one rolling the little stone a fraction of a degree, smoothing it like a jeweler polishing glass. Now lift your eyes from the pool to the wall. There, you might see flowstone sheets of mineral that look like melted candle wax, frozen mid-pour. Flowstone forms when thin films of water glide down a sloping surface, leaving behind layer after layer of calcite, the same mineral that makes seashells and chalk. A single millimeter of flowstone can take 100 years to grow. A sheet as thick as your thumb might be older than the pyramids. A drape that reaches from ceiling to floor, taller than a person, can be older than the last ice age. The scale here is hard to hold in the mind. If you imagine the life of a single human as one slow breath, the growth of a stalagmite, the height of a child, would be roughly 100,000 breaths laid end to end. The cave does not hurry. The cave does not notice us at all. Some of these formations look like frozen waterfalls. They cascade down the rock in soft folds, glowing pale gold or milky white under a lamp. The largest can stand 20 meters tall, about the height of a 6-story building, and weigh hundreds of tons. Yet they are made entirely of water that arrived one drop at a time. If you could collect every drop that built such a waterfall and pour it into a single river, it would flow for only a few quiet minutes. The mass is enormous. The pace is almost nothing. And then there are the smaller wonders that hide near your feet. Tiny soda straws, hollow, fragile tubes of calcite, hang from the ceiling like pale glass needles. The thinnest are no wider than a pencil lead. Some are over a meter long. Many have grown undisturbed for 50,000 years. A single careless breath of warm air can change how they form. A single touch can stop them forever. The contrast is the marvel. A cave pearl the size of a grape, a flowstone curtain wider than a house, both made by the same gentle drip, both shaped by water that probably fell as rain when mammoths still walked the plains above. Here is where the open question slips in. Researchers can measure the layers inside a stalagmite the way you might count rings in a tree. Each layer holds a tiny clue about the climate above, how warm it was, how wet, how much dust drifted in the air. But the rate of growth changes with every shift in weather. So when scientists try to read these stone records, they cannot always agree on what each layer means. One team may read a pale band as a wet century. Another may read the same band as a dry one. The cave keeps its diary, but the handwriting is faint, and the language is not fully translated. There is also a quieter mystery. Some cave pearls grow in pools where no obvious water drips today. The pools sit still. The pearls keep their polish. How do they stay so round, so smooth, in such silence? One idea is that the air itself carries enough moisture to keep them turning, ever so slightly. Another is that they were finished long ago, in a wetter age, and we are simply seeing the leftover beauty. No one knows for sure. So picture it now as you rest. A dark chamber, a drip every few minutes, a pearl the size of a pea, turning once in 100 years. A frozen waterfall, 6 stories tall, made of patience. All of it grown in the dark, with no one watching, for longer than any human story has been told. Picture for a moment a hole in the ground high in a quiet mountain forest. It does not look like much. The opening is narrow, maybe the width of a small doorway, framed by mossy limestone and pale roots. Cold air drifts up from it, even in summer, carrying the smell of wet stone. A few birds call from the trees. The wind moves through the pines, and yet, beneath that small dark mouth, the earth drops away for more than 2 kilometers straight down. This is the surface of the deepest known cave system in the world. From above, you would never guess. The mountain looks like any other mountain. Gray ridges, green slopes, scattered patches of snow clinging to the higher places. Goats might wander past. Clouds might drag their soft bellies across the peaks. The entrance sits quietly among rocks and grass, almost shy, as if it does not want to be found. The cave is called Vuryevkina, and it lies in the Arabica Massif in the Caucasus Mountains, near the Black Sea. To stand at that mouth is to stand at the lip of something almost beyond imagining. The first drop is short, then another, then another. Cavers descend on ropes through shaft after shaft, each one carved by water that vanished into the limestone long ago. The walls are pale gray, sometimes white, sometimes streaked with rust where iron has bled out of the stone. In places, the rope hangs free in the dark, turning slowly, while the caver spins above a void no flashlight can fully fill. The surface above gives no warning of this. It looks like ordinary alpine country. Hikers walk over it without knowing. Sheep graze on the thin grass. somewhere beneath their hooves, a chamber the size of a cathedral sits in perfect silence, filled with cold black water. Another famous deep cave nearby, Krubera, also called Voranya, plunges more than 2 kilometers as well. The two caves sit close together in the same range, and explorers still wonder if they might one day be found to connect through some passage no one has yet squeezed through. From the surface, the Arabica Massif looks worn and gentle. Rolling limestone uplands, sinkholes scattered like shallow bowls, wildflowers in the warmer months. But the rock beneath is riddled with passages, like a sponge made of stone. Rain that falls on these slopes does not run away into rivers the way it does in most places. It sinks. It disappears into cracks. It travels downward for days, sometimes weeks, finding its way through tunnels that no human will ever see, before emerging in springs near the coast far below. To picture the scale, imagine stacking 7 of the tallest buildings ever built on top of each other, and then lowering that whole tower into a single shaft of darkness. That is roughly the depth cavers have reached in Vuryevkina, and still the bottom may not truly be the bottom. The deepest point they have found so far is a sump, a place where the passage fills completely with water and continues onward beneath the surface of an underground lake. Divers have pushed a little farther. No one yet knows where it ends. The colors down there are limited, but strange. Limestone in pale cream and dove gray. Walls slick with moisture that catches the headlamp in tiny diamond points. Mud the color of milky coffee. Pools so clear they seem to vanish, until a stone tossed in proves the water was there all along. In the deepest chambers, the air is heavy and still, and sound carries in odd ways. A whisper can feel loud. A shout can come back as a soft hum. What remains genuinely open is how deep caves can really go. Vuryevkina is the deepest we have measured, but the limestone of the Arabica Massif may hold passages deeper still. Some geologists suspect there are systems elsewhere in the world, perhaps in the mountains of New Guinea or southern China, that could rival or surpass it. Others think we may already be close to the practical limit of how deep a cave can form before the surrounding rock simply closes itself under pressure. Both ideas remain unproven. Both wait for someone to find a new shaft, a new sinkhole, a new mouth in some quiet mountainside. So the surface above the deepest cave in the world looks ordinary. Grass, stone, wind, a small dark opening, and beneath, a hollow vastness that has been carved over millions of years by water moving in patient silence. We have seen only part of it. The rest is still waiting, somewhere below the soft sound of the breeze. Not every cave is born from water. Some are born from fire. Deep beneath old volcanoes, in places where the ground once ran red with molten stone, there are long, hollow tunnels carved by rivers of lava. They are called lava tubes, and they are some of the strangest passageways on Earth. Walking through one feels like walking through the throat of a sleeping dragon, long since gone cold. A lava tube forms in a way that almost seems impossible. When a volcano spills its molten rock across the land, the outside of that flowing river begins to cool first. The air touches the surface, and a thin crust hardens over the top. Underneath that crust, the lava keeps moving, still hot, still glowing, still pushing forward like a hidden current. When the eruption finally ends, the last of the lava drains away. What remains is an empty tunnel with smooth walls and a ceiling of stone, sometimes stretching for miles. The walls of a lava tube look nothing like the walls of a water cave. They are dark and glassy in places, ribbed in others, sometimes the deep color of black coffee, sometimes streaked with red or rust, or a faint metallic sheen. The ceilings often hold small drips of frozen stone called lavasicles, hanging like teeth where the last molten drops cooled mid-fall. The floor can be smooth and rolling, almost like a road, or it can be jagged and broken where the final flow tore itself apart. Some lava tubes are small enough that a person has to crawl through them. Others are vast. On the island of Hawaii, the Kazumura tube runs for more than 40 miles under the slopes of a volcano, dropping nearly a kilometer in elevation as it goes. In South Korea, the Manjingal tube stretches in long, echoing chambers wide enough to fit a small house. And on the slopes of Mount Etna in Iceland, on the high plains of East Africa, there are tubes still being mapped, still giving up new chambers no one has ever stood inside. What makes lava tubes especially mysterious is how little we know about how far they reach. Unlike water caves, which often hint at their presence with springs or sinkholes, lava tubes can lie hidden under thick layers of soil and vegetation. Their entrances are sometimes no wider than a single crack in the ground. A whole network may run beneath a forest for centuries without anyone suspecting it is there. Researchers wonder how many lava tubes still wait, unfound, beneath old volcanic fields in places like the American Southwest, the Canary Islands, and the high deserts of Patagonia. The life inside these tubes is its own puzzle. Without sunlight, without flowing water in many cases, the conditions are harsh. Yet scientists keep finding small living things tucked into the cracks. There are pale spiders, blind beetles, and slow-moving creatures that seem to have evolved entirely in the dark. Some lava tubes hold colonies of microbes that feed on minerals in the rock itself. How these organisms arrived and how long they have been there remains an open question. One idea is that they crept in slowly from the surface over thousands of years. Another suggests that some of them may have lived in the rock long before the tube ever formed. There is also the question of what lava tubes can tell us about the deep heat below. Each tube is a kind of fossil, a frozen record of how lava once moved through the ground. By studying the shape of a tube, the thickness of its walls, the patterns left in its floor, researchers can read the story of a single eruption from long ago. But the deeper questions about why some eruptions form tubes and others do not, about how lava behaves under pressure inside the earth, are still being argued over. The physics of molten rock is not as well understood as it might seem, and there is one more wondering that lingers in the quiet of these caves. Some lava tubes have ceilings strong enough to shelter people, to shelter water, to shelter delicate things from the harsh weather above. Long ago, humans took refuge in them, painted on them, buried things in them. What other tubes, sealed off and forgotten, might still hold traces of those long ago visits? No one can say. The lava cooled, the doorways closed, and the tunnels wait, patient and dark, beneath the green hills that grew over them. We do not yet know how many there are, or how deep they go, or what stories they still keep folded inside their long stone silences. Along the edges of the continents, where land meets sea, the ocean works on stone in a different way than the slow drip of rain in a limestone hill. Here, the carving is loud. Waves rise and fall against the cliffs, hour after hour, day after day, for thousands of years. And in the soft seams of those cliffs, sea caves begin to form. They are some of the youngest caves on Earth, and also some of the most rhythmic. Their entire shape is tied to the breathing of the tides. A sea cave often starts at a weak spot in the rock. Maybe a crack runs through a cliff of basalt. Maybe a band of softer stone sits between harder layers. The waves find that weakness and push into it. Each wave compresses the air inside the crack, then pulls back, sucking water and pebbles out again. Over time, this slow hammering widens the opening. Sand and stones spin inside the hollow, scouring the walls like wet sandpaper. The cave grows by being polished from within. The tides give these caves their pulse. Twice a day, in most places on Earth, the sea rises and falls. At high tide, a sea cave may fill almost to its ceiling, dark water sloshing against smooth walls. At low tide, the same cave may sit half empty, its floor of wet pebbles exposed to the air. The cave is never the same room twice. It breathes with the moon, slow and steady, in a rhythm older than any human language. Some sea caves have a blowhole at the back. When a large wave pushes in, the water has nowhere to go. It rushes up through a narrow shaft in the roof and erupts into the sky as a fine, hissing spray. From the clifftop above, you might see only a soft plume of mist rising every few seconds. The cave is exhaling. Below, in the dark chamber, the sound is something like a deep cough of the sea itself. The colors inside a sea cave often surprise visitors. Light bounces off the water at the entrance and reflects up onto the curved ceiling, painting it in shifting blues and greens. On calm days, the inside of a sea cave can glow a soft turquoise, lit from below by sunlight filtering through clear water. On stormy days, the same cave is black and roaring, full of foam. Two faces of the same room, set by the mood of the sea outside. Sea caves are short-lived, as caves go. A limestone cave inland may take 1,000,000 years to form and last for many millions more. A sea cave may form in only a few thousand years and may collapse just as quickly. The same waves that carve it also weaken it. Eventually, the roof falls in. What was once a hidden chamber becomes a narrow inlet open to the sky, then a notch in the cliff, then nothing at all. The cave returns to the shoreline that made it. There is an open question here, quiet but real. We do not fully know how fast sea caves come and go on a global scale. Some scientists wonder whether changes in sea level over the past ice ages left behind whole networks of drowned sea caves, now sitting far below the modern shoreline. Other researchers think many of those older caves have already collapsed, erased by the same forces that carved them. The evidence is hard to gather because the work happens in surf zones where divers struggle to map anything safely. So the true number of sea caves on Earth, past and present, remains a soft guess. There are also caves where fresh water meets salt water inside the rock itself. Along certain coasts, rain seeps down through limestone from above, while the sea pushes in from below. The two waters meet in a hazy boundary layer called a halocline, where light bends in strange ways. Divers describe swimming through what looks like liquid glass, as if passing from one room into another without moving. How these mixed caves form and how widespread they may be along the world's coastlines is still being studied. For tonight, picture a sea cave at dusk. The tide is going out. Water slides back across smooth stones with a soft hiss. The walls drip quietly. Somewhere deeper inside, a single drop falls from the ceiling and lands in a shallow pool. Outside, the ocean keeps its old rhythm, rising and falling, rising and falling. The cave waits, patient, half asleep, listening for the next wave. It has been listening for thousands of years. It will keep listening in its slow tidal breath long after this quiet night is gone. caves are carved from stone. Some of the most beautiful hollows on Earth live inside ice, hidden within the bodies of sleeping glaciers. These are the ice caves, and they belong to a different family than the limestone caverns we have been wandering through. Their walls do not hold the memory of ancient seas. Their ceilings are not built from minerals dripping down through the dark. Instead, they are shaped by meltwater, by pressure, by wind, and by the slow breath of glaciers that move only inches each year. To stand inside one is to stand inside a sapphire. The light that filters through thick glacial ice loses its warmer colors along the way. Red and yellow are absorbed by the deep crystal lattice, and only blue is left to wander through. So the walls glow with a soft, otherworldly blue, sometimes pale as a winter sky, sometimes deep as the heart of the ocean. The surface is smooth in places, rippled in others, polished by water that once flowed through and then froze again. Ice caves form in a few different ways, and each one tells a slightly different story. Some are carved by meltwater rivers that run beneath the glacier in the warmer months. These rivers tunnel through the ice like underground streams in limestone country, hollowing out winding passages that twist and turn for hundreds of feet. When winter comes and the water freezes or drains away, what remains is a tunnel of pure ice. Other ice caves are shaped by warm air rising from the ground beneath the glacier, slowly melting the underside into pockets and rooms. A few are born from geothermal heat, where volcanoes sleep beneath the ice and breathe gentle warmth upward, opening chambers near the bedrock. The glaciers themselves are neighbors to the cave world in a strange and quiet way. A limestone cavern can sit unchanged for hundreds of thousands of years, its stalactites growing one drop at a time. An ice cave is a much shorter story. It may exist for a season or a decade, or sometimes longer, but it is always changing. The roof may sag. A new passage may open. An old chamber may close as the glacier shifts above it. Cavers who visit ice caves often return to find the layout completely rearranged, as if the cave itself had moved house while no one was looking. This impermanence is part of what makes them mysterious. Geologists know the broad outlines of how these caves form, but the fine details still raise open questions. How long, on average, does a given ice cave last before it collapses or refreezes? What controls the shape of the patterns on the walls, those swirling ridges and scalloped curves that look almost carved by hand? Some researchers think the patterns are sculpted by the way meltwater currents swirl through the tunnel, leaving behind a record of every eddy and ripple. Others wonder if wind plays a larger role, especially in caves that open to the surface. The evidence is incomplete, and each cave seems to keep some of its secrets. Inside the deepest ice caves, a faint sound can sometimes be heard. It is the glacier itself, groaning and cracking under its own weight. Glaciers are not still. They flow slowly, like very cold honey, and as they move, the ice fractures and resettles. A visitor standing in an ice cave may hear small pops, distant rumbles, the occasional sharp report of a crevasse opening somewhere far above. The cave is alive in its own slow way. There are also creatures that have learned to live at the edges of this world. Tiny ice worms inhabit some glaciers, thread-like animals dark against the pale ice. They feed on algae and bacteria that survive in the thin meltwater films. How they tolerate the cold so completely remains an open question. Their cells should not function at temperatures so close to freezing, and yet they do. Some researchers are studying them to understand what kind of life might be possible in icy worlds elsewhere in our own solar system. Though the question of how the worms themselves manage it on Earth is still not fully answered. Ice caves and stone caves rarely meet, but they are cousins. Both are hollow places shaped by water. Both glow with their own quiet light when a lamp is brought inside. Both feel ancient, even when one of them is, in cave terms, very young. To stand in a blue ice chamber is to be reminded that the underground world is not only made of rock. It is made, sometimes, of frozen rivers and sleeping glaciers, holding their breath until the next thaw. Deep inside certain caves, on floors of soft clay or hardened mud, there are footprints, not animal tracks, not modern boot prints, human footprints pressed into the ground tens of thousands of years ago, preserved in the still air and the steady, cool dark. They sit there now, exactly where they were left, as if the walker had only just stepped away. In a cave in southern France called Chauvet, the soft floor holds the prints of a child. The tracks are small, and they wander through a chamber lit only by the torch the child must have carried. Scientists believe these prints may be around 26,000 years old. Beside the child's footprints, in some passages, there are also the paw prints of a large canid, perhaps a wolf, perhaps a very early dog. Whether the two walked together or passed through at different moments, no one can say. The clay holds the steps, but not the story. Another cave, this one in Italy, holds even older traces. Inside a system known as Basra, researchers have found the prints of several people, including small children who appear to have crawled and walked deep into the cave together. Charcoal smudges along the walls suggest they carried torches and brushed them against the stone to refresh the flame. The footprints, there are thought to be around 14,000 years old. The group went in, moved through narrow passages, and came back out. Why they went so deep into the dark remains an open question. In Tanzania, far from any cave, volcanic ash once held the footprints of 3 early human ancestors who walked across a wet plain more than 3 million years ago. Those are not cave prints, but they share the same quiet magic. Soft ground, a footstep, and then conditions just gentle enough to preserve the shape for an unimaginable stretch of time. Caves are some of the best places on Earth for this kind of preservation. The air stays still. The temperature barely changes. Floods are rare. A footprint pressed into the right kind of clay can outlast empires, languages, and entire human cultures. The oldest known footprints inside a cave may belong to a site in Romania called Rizbuk. There, on a layer of cave mud, more than 200 prints were found, left by what researchers believe were a small group of early modern humans. Estimates of their age vary, but some studies place them at around 36,000 years old. Adults, adolescents, and children all seem to have walked through together. Why a whole family group ventured so far underground in flickering torchlight with no clear practical reason, is something no one has answered. One theory is ritual. Another is curiosity. A third is simple shelter. The prints themselves give no opinion. The extremes of cave footprints go beyond age. Some are remarkable for depth. In certain European systems, prints have been found more than a kilometer from any natural entrance, deep inside passages that would have required hours of careful movement by torchlight. Others are remarkable for who left them. In a cave in southeastern Asia, researchers have found tracks they think belong to ancient humans alongside the tracks of extinct megafauna. The animals and the people seem to have shared the same dark spaces, at least sometimes. There are also prints whose makers we cannot identify with confidence. In a few caves, hand and foot impressions have been found that some researchers attribute to children, while others suggest the proportions may be unusual enough to belong to a different group of early humans entirely. The bones of Neanderthals, Denisovans, and other relatives have turned up in caves around the world. Whether any preserved footprints belong to those cousins rather than to our own ancestors remains debated. The shape of a print can only tell us so much. What unites all these traces is their stillness. A footprint is a single second of motion, frozen. The person who left it stood there, shifted their weight, lifted their foot, and walked on. The cave kept that second for us. We can stand beside it in modern light and look down at the exact spot where a stranger from deep time paused for a breath. We do not know their name. We do not know what they were thinking. We do not know whether they were afraid of the dark or comfortable in it, or there for reasons we would recognize at all. The prints wait, quiet on the clay, in chambers that have not changed in any meaningful way since the moment they were made. The question of who walked there and why sits gently in the cool, unmoving air. Deep inside certain caves, on walls that have not seen sunlight in tens of thousands of years, there are paintings. Soft red horses, black bulls with curling horns, herds of deer that seem to drift across the stone. Some are smaller than a hand. Some stretch longer than a grown person is tall. They were made by people who lived in a world we can barely picture, and they remain one of the quietest, strangest gifts the underground has ever offered us. The pigments themselves are a small wonder. The reds come from iron-rich earth, ground fine, and mixed with water or animal fat. The blacks come from charcoal or from a soft mineral called manganese. The yellows come from clays warmed by ancient sun. These colors should have faded long ago, but sealed away in the cool, still air of a deep chamber, they have held on. The same darkness that hides the caves has also protected them. Look closely at one of these walls, and you begin to see how careful the painters were. They did not always paint on flat stone. They followed the natural curves of the rock. A bulge in the wall becomes the rounded shoulder of a bison. A crack becomes the line of a horse's back. A shadow in the rock becomes an eye. The animals seem to lean out of the stone, as if the painters were not inventing them, but uncovering them. What the artists were thinking when they did this, we cannot say. One idea is that they believed the animals already lived inside the stone, waiting. Another is that they simply loved the shapes they saw. The question stays open. Even the smallest marks hold mysteries. On some walls, there are rows of dots, tiny red circles, evenly spaced, marching along the rock. On others, there are handprints, made by pressing a palm to the wall and blowing pigment around it through a hollow bone. The hands left behind are pale ghosts, framed in soft color. Some are large. Some are small enough to belong to a child. They are quiet, personal signatures left in the dark, and no one alive knows the names that go with them. There are also marks that no one has fully explained. Lines, crosshatches, spirals, little ladder shapes, patterns of dots that repeat from cave to cave across thousands of miles. Some researchers wonder if these signs were a kind of early counting. Others wonder if they tracked the seasons, or the movements of animals, or the cycles of the moon. Still others suggest they were simply patterns the artists liked. We do not yet know which idea, if any, is correct. Under a microscope, the surface of these paintings becomes its own small landscape. The pigment sits in tiny grains, packed into the rough texture of the stone. Over time, a thin veil of calcite, the same mineral that build stalactites has slowly settled over many of the paintings. This pale layer is what has helped scientists figure out their age. By measuring the slow growth of that veil, researchers can guess how long ago the pigment was laid down. Some of these dates reach back more than 30,000 years. A few may reach further still. That is part of what makes these chambers so quiet and so strange. The painters worked by the light of small stone lamps, burning animal fat with a soft yellow flame. The light would have flickered. The shadows of the animals would have moved on the walls. We can picture the scene, but we cannot enter it. The voices, the footsteps, the meaning of the marks, all of it has gone silent. There are also caves with no paintings at all, but with something even simpler. Soft finger lines drawn through the clay coating on the walls. Whole panels of these gentle grooves, made by trailing fingertips across the soft surface. Some look like patterns. Some look like nothing in particular. In a few cases, the small hands of children appear among them, the prints clear in the clay. It is one of the most tender things the underground has kept for us, and one of the least understood. Why people went so deep to make these marks, we cannot fully say. Some chambers lie far from any place where humans could have lived. The painters had to crawl, climb, and squeeze through narrow passages, carrying their lamps and pigments just to reach the chosen wall. Whatever drew them there mattered enough to risk the dark. The walls remember. The reasons do not. And tonight, in the quiet glow of those painted herds, the question still waits, patient and unanswered in the deep. Deep inside a cave, far from any opening, the explorer often finds something that stops them in their tracks. A lake, black, still, and so quiet that the silence itself seems to have a weight. The first people to lower a lantern over such water did not know what to make of it. They watched their own faces float back up from the dark glass below, and they wondered how deep it went. They wondered if anything lived in it. They wondered, most of all, why it was so completely still. The history of how humans learned about these hidden lakes is a slow and patient one. For thousands of years, people drew water from underground springs without ever seeing the chambers that held it. Wells in old villages would suddenly run dry or suddenly rise, and no one could say why. In dry country, a goat might fall through a thin patch of ground and tumble into a pool no human had ever touched. The villagers above heard only the echo. They built stories around that echo, but they had no way to look inside. The real exploration began in the late 1700s and through the 1800s, when a small group of curious naturalists started crawling into caves on purpose. They carried oil lamps, candles, and lengths of rope. They sketched what they saw by flickering light, and their drawings often showed a flat black shape at the bottom of a chamber, labeled simply as water. They did not always know if it was a pond, a river, or something much larger. The lamps could not reach across it. The sound of a dropped stone gave them only a guess. One of the first careful studies of underground lakes came from work in the limestone country of Central Europe, in a region called the Karst. A Slovenian explorer named Janez Vajgerd Valvasar wrote about strange lakes that filled and emptied on their own, long before anyone understood the plumbing beneath. Later, in the 1800s, a man named Jovan Sivijic walked these same hills and began to map how surface water sank into the rock and pooled in chambers below. He gave us much of the language we still use for cave country today. Yet even he, standing at the edge of a black underground lake, could only describe what his lamp could reach. The tools came slowly. Plumb lines, knotted ropes with weights, were lowered into the water to measure depth. Sometimes the line went down 10 meters. Sometimes it went down 100 and kept going. In the early 1900s, divers began to suit up in heavy canvas and brass and walk into cave pools on weighted boots. The air was pumped down to them through long hoses, and a single tangle could mean disaster. They came back with stories of passages that bent down and away into a deeper dark. They could not always say where those passages led. By the middle of the 20th century, cave divers began using compressed air tanks, and a new chapter opened. They swam into flooded tunnels that had never seen any light at all. They found rooms beyond rooms, lakes connected to lakes, water that traveled for miles beneath stone. In the the cenotes of the Yucatan, divers slowly traced ancient networks the Maya had treated as sacred long before anyone knew their true size. Some of those networks are still being mapped today, and still the silence remains the strangest part. A lake on the surface ripples with wind, with insects, with the small movements of fish near the edge. A lake deep inside a cave has none of these things. The air above it does not move. No sun warms it. No rain falls on it. The water can sit undisturbed for centuries. When a diver finally enters, the disturbance they make is the first the lake has known in a very long time. What we still do not know is how many of these lakes exist, or how they are linked. One idea is that many cave lakes are simply isolated pools, fed by slow seepage through the rock. Another idea is that they are windows into vast hidden aquifers, all quietly connected, sharing water across distances we cannot yet measure. Dye traces sometimes reveal surprising connections between pools that seemed unrelated. Other times, the dye simply vanishes, never reappearing anywhere a human can see. The history of discovery, then, is really a history of listening at the edge of dark water and slowly learning how little we knew. Each generation has reached a little further. Each generation has also stood at a new edge, lamp in hand, and asked the same old question: what is down there, and how far does it go? Deep beneath a mountain in the north of Mexico, hidden under hundreds of feet of solid limestone, there is a chamber that almost seems too strange to be real. Inside it, vast pale beams of crystal lean across the room like the fallen columns of some forgotten temple. Some of these beams are longer than a school bus. Some weigh as much as a small whale. They are made of selenite, a soft, glassy form of gypsum that catches the light like frozen honey. And until the year 2000, almost no human eye had ever seen them. The chamber is called the Cave of the Crystals. It sits about 1,000 feet below the surface, near an old silver and lead mine. Miners pumping water out of the deep tunnels broke through into the void by accident. What they found stunned every geologist who came after. Crystals the size of pine trees, growing in every direction, smooth and translucent and impossibly large. Most crystals in most caves are small. A fingertip of quartz here, a thumb of calcite there. But these selenite beams grew to lengths of nearly 40 feet. The question every scientist asked was the same. How could a crystal grow that big? What conditions would the earth need to hold, steady and unbroken, for that to happen? The leading idea is patience, a patience almost beyond imagining. Researchers studying the chamber believe the crystals grew very, very slowly in water that stayed at almost exactly the right temperature for hundreds of thousands of years. Perhaps 500,000, perhaps longer. The water sat at around 136 degrees Fahrenheit, warm enough to keep gypsum dissolved, but just cool enough to let it slowly settle into solid form. A few atoms at a time, across geological ages, without a single major disturbance. That stillness is the part that feels almost impossible. The earth above shifts and shakes. Ice ages come and go. Rivers change their paths. Yet inside this one pocket of warm mineral water, nothing important changed for 500,000 years. No earthquake cracked the chamber. No flood washed it clean. No temperature swing dissolved the slow work. The crystals simply grew and grew and grew in perfect quiet. There are other crystal caves scattered across the planet, though none quite like this one. A smaller chamber nearby, called the Cave of Swords, holds shorter, sharper selenite blades. Some researchers believe it formed in cooler water that cooled too quickly, ending the growth before the crystals could reach giant size. The two chambers may be twins, separated by temperature alone. One reached its full size. The other did not. What scientists still wonder about is how common these hidden crystal rooms might be. Most caves are explored only where humans can already reach them. The Cave of the Crystals was found only because miners drained the water. Without the pumps, the chamber would still be flooded, still growing, still secret. Other selenite chambers could exist beneath other mountains, in other warm pockets of mineral water, completely unknown. There may be crystals out there even larger than the ones in Mexico. We simply have no way to know. There is another strange detail. The crystals are slowly dying. Once the miners pumped the water out, the chamber filled with air. Air is the wrong medium for selenite. The crystals begin to dehydrate. The surfaces dull. Tiny cracks appear. The very act of discovering them may be ending their long, quiet growth. Some scientists have suggested flooding the cave again, letting it return to the dark, warm water, so the crystals can resume their slow work for another 100,000 years. Others believe the chamber should remain open, at least for a little while, so that the world can study what was found. Inside the chamber, the heat is brutal. Temperatures can reach over 120 degrees Fahrenheit, with humidity so thick the air feels like warm broth. Explorers can stay only minutes at a time, even with special cooling suits. The crystals shine softly under their lamps, glass pale, glass smooth, with a faint inner glow. Walking among them, researchers have said, feels less like exploring a cave and more like stepping inside the interior of a geode the size of a cathedral. And the question lingers: if a chamber this remarkable went unseen until the year 2000, hidden in a mountain humans had been mining for over a century, what else might be waiting in the warm dark? How many more cathedrals of crystal sit beneath our feet, growing patiently, atom by atom, in pockets of still water that we have not yet reached? The answer, for now, remains in the stone. There is something many people do not expect about caves. They breathe. If you stand near the mouth of a deep cavern on a still day, you can sometimes feel a soft current of air on your skin. Sometimes it moves outward, drifting into the forest. Sometimes it moves inward, pulled gently into the dark. The cave is not alive in the way we are, yet it inhales and exhales on its own quiet schedule, in a slow rhythm that can stretch across hours or even seasons. This breathing connects the world below to the world above in ways that scientists are still working to understand. The air inside a cave is rarely still. It moves because of small differences in temperature, in pressure, and in moisture between the underground passages and the open sky. When the air outside grows colder than the air inside, the warmer cave air rises and slips out through the upper openings. Cooler outside air sinks down through the lower ones to take its place. When the seasons reverse, the flow reverses with them. The mountain itself seems to draw breath, then let it go. In some caves, the wind is gentle, barely enough to stir a candle flame. In others, it can roar through narrow passages like a steady gale. Cavers have learned to follow these breezes the way sailors once followed trade winds. A draft moving through a tight crack often means there is a larger chamber on the other side. The air is whispering about rooms no human has ever seen. These breaths do more than move dust. They carry moisture, carbon dioxide, and tiny spores between the surface and the deep. They shape the formations on the walls. They feed the microbes clinging to wet stone. They influence which animals can live in which passages, and how far life can reach into the darkness. A cave that breathes freely tends to grow different crystals than one that holds its breath. The exchange of air is part of how the cave sculpts itself slowly over thousands of years. The connection runs further still. Caves help regulate the temperature of the ground above them. They store cool air in summer and trap mild air in winter. The soil and rock that sit on top of a cave system behave differently than soil with solid bedrock beneath. Plants growing over hidden chambers sometimes sense the difference. Their roots find pockets of moist air rising from below. Certain forests, certain meadows, certain springs may exist exactly where they do because of the breathing caverns underneath them. Even rainfall enters this conversation. When storms move across the surface, air pressure drops. The caves respond by exhaling more strongly, pushing humid air out into the world. When high pressure returns, they draw fresh air back inside. Some researchers have measured this so carefully that they can almost predict the weather by watching the wind at a cave mouth. The atmosphere above and the atmosphere below are joined by these slow, patient lungs of stone. Scientists are still puzzling over the larger picture. How much of Earth's air passes through caves each year? How much carbon dioxide the limestone walls quietly absorb as the moist air drifts past? How the gases trapped underground may affect the climate above on long timescales. One theory suggests that vast cave networks act like hidden filters, slowly trading molecules with the atmosphere in ways that gently shape the chemistry of the planet. Another view holds that the contribution is small, almost invisible against the size of oceans and forests. The truth likely sits somewhere between, and the measurements are difficult to gather. Most caves remain unmapped. Most breaths go uncounted. There is also the question of what the breathing carries that we cannot see. Microbes ride the air currents in and out. Pollen from ancient eras can be lifted from buried sediment and released to the wind. Cave breath may even carry traces of chemistry from deep within the earth, gases seeping up through cracks and joining the atmosphere through quiet stone mouths. Each exhale is a small message from below. Stand at a cave entrance at dusk, and you may feel that message on your cheek. A soft, cool current moving past you. A reminder that the ground beneath your feet is not solid the way it seems. It is layered, hollow in places, connected to the sky in long, invisible threads. The cave breathes, the forest breathes, the ocean breathes. Together, they form a single slow rhythm that has been going on far longer than any of us has been listening, and which still holds secrets that no instrument has yet been clever enough to read. Nothing in the underground world stays still. The stone seems eternal, but it is only patient. Water moves through it grain by grain, year by year, hollowing out spaces no one sees. And sometimes, after centuries of quiet work, the ceiling of a hidden chamber gives way. The ground above sighs and falls inward, and a sinkhole opens to the sky. Sinkholes are the moments when the slow story of caves becomes sudden. For thousands of years, rainwater seeps down through soil and cracks. It picks up a little acid from the air and from rotting leaves. That mild acid eats at limestone, grain by grain, opening tiny passages. The passages join. The passages widen. A room forms in the rock, sometimes the size of a house, sometimes the size of a stadium. Above it, the surface looks ordinary. Grass grows, roads are paved, people build homes, and below, the ceiling thins. The collapse, when it comes, can feel like a single event. But it is really the end of a long, quiet process. Geologists call this kind of country karst, a landscape shaped by water dissolving stone underneath. In karst regions, sinkholes are simply how the land breathes. Florida has them. Mexico has them. Slovenia, China, and the limestone hills of Vietnam are dotted with them. Some are small, no bigger than a garden pond. Others are wide enough to swallow a small village square. The most striking ones go straight down into clear blue water. These are called cenotes, from an old word in the Maya language. Cenotes appear when the ceiling of a flooded cave falls in, leaving a deep round window into the groundwater below. The water is often still and cold and astonishingly clear. Light reaches a certain depth and then fades into a soft blue. Below that, divers have followed tunnels for miles. No one knows yet how many of these underground rivers truly connect, or how far they reach beneath the forest. In other places, sinkholes form a slow staircase of change. A single field may sag a little each year. Trees lean. Fence posts tilt. Then one morning, a soft circle of grass simply isn't there anymore. The ground has not vanished. It has only moved into a room that was waiting beneath it. Engineers can sometimes predict these collapses with careful surveys, but not always. The deep map of the underground is still mostly unknown. The largest sinkholes on Earth are called Tiankang, a Chinese word that means something like sky pit. The most famous ones lie in the green hills of southern China. They drop hundreds of meters straight down, with vertical walls draped in moss and ferns. At the bottom, a small forest sometimes grows, sheltered and damp, watered by mist from a hidden river. Birds nest in the high walls. Cool air drifts up from caves at the base. These places feel like worlds folded inside the world. One open question is how quickly the underground is changing today. Some researchers wonder if heavier rainfall and changing groundwater levels are speeding up the formation of new sinkholes. Others think the timing only seems faster because more people now live above karst country, and so more collapses are noticed. The evidence is mixed. The rock dissolves at its own pace, but the water that drives the process is shifting in ways that are still being measured. There is also the deeper question of how many hidden ceilings already wait beneath us, thinned almost to the point of giving way. No one can say. Ground-penetrating radar reveals only the shallow layers. Deeper rooms remain dark to instruments and to imagination alike. Some may persist for thousands more years. Some may open before the next sunrise. The honest answer is that we do not know which is which. What we can say is that the underworld is not a finished place. It is still being carved. Every drop of rain that vanishes into a crack is part of an ancient sentence being written. Every tiny grain of limestone carried away in dark water makes some far ceiling a little thinner. The caves we see today are only the current draft. In 100,000 years, this draft will be unrecognizable. Passages will widen. Rooms will join. Some will fall in and become sunlit bowls of green. Others, not yet imagined, will form in the silence. For now, sinkholes remind us that what looks solid is sometimes a roof, and under that roof, slow water has been working for a very long time, with no urgency at all, on rooms we have not yet entered, and on rooms no one will ever see. The earth keeps shaping itself gently while we go about our days. There is a kind of light that belongs only to deserts. It is low and golden in the morning, white and pitiless at noon, and soft pink in the long hour before dusk. It moves across the sand the way water moves across glass. And under that shifting light, for thousands of years, people have wondered what lies beneath the dunes. Not just stone, not just bones, whole cities, perhaps, streets and walls and rooms still standing in the dark, waiting under the warm weight of the sand. The stories are old. In the deserts of Arabia, travelers spoke of a city called Ubar, a place of high towers and rich gardens, said to have sunk into the sand as punishment for its pride. In the Sahara, nomads told of buried oases where caravans once stopped to drink. In the Gobi, herders spoke of stone rooms hidden beneath the dust, lit only by the thin light that fell through cracks in the ceiling. These tales were not all the same, but they shared a quiet idea that the desert had swallowed things, that something was still down there. Some of these legends turned out to hold a grain of truth. In the early 1990s, Researchers using satellite images noticed faint lines crossing the southern Arabian sands. The lines were old caravan tracks worn into the desert long ago and still visible from above. Where the tracks gathered together, they led to a ruined site at a place called Shisser. Some believed this was the lost city of Ubar, or at least a trading post connected to its legend. Others were not so sure. The ruins were real, but the city of towers from the old stories was not. The mystery did not close. It only shifted. Light is the reason we can search at all. Sunlight bouncing off the sand reveals shadows and shapes that hint at buried walls. Radar pulses, which are a kind of invisible light, can pass through dry sand and bounce back from stone beneath. From orbit, scientists send these pulses down and listen for echoes. In some places, the echoes have revealed old riverbeds, lost lakes, and the faint outlines of ancient structures hidden under the dunes. The desert is not as empty as it looks. It is layered, and light, in many forms, is how we read those layers. Beneath the sand, of course, there is also true darkness. In some desert regions, the soft stone below has been carved into caves by water that flowed there long ago, when the climate was wetter and greener. The Sahara was once a land of lakes and grasslands. Rock paintings in its hidden shelters show giraffes, cattle, and swimmers. When the rains stopped and the sand came, those caves and shelters were sealed away. Some still hold their paintings. Others may hold more. We do not know how many remain unfound. The idea of a true buried city, with rooms and streets intact, is harder to support. Sand is heavy. It crushes wood and collapses ceilings over time. Yet there are real examples that keep the imagination alive. The ancient Egyptian town of Tanis lay under desert, silt for centuries, before being slowly uncovered. Parts of the city of Petra, carved into rose-colored stone, were buried under sand and rubble, until explorers cleared them in the 1800s. In Central Asia, whole Silk Road towns vanished as the dunes advanced, then reappeared, weathered and quiet, when the wind shifted again. So the question lingers: how much is still down there? One view is that the great age of desert discovery is mostly behind us, and that satellite surveys have already found the major sites. Another view is that we have barely begun. Vast stretches of the Sahara, the Arabian Peninsula, the Taklamakan, and the Gobi have never been walked by an archaeologist. The sand keeps its own record, and the record is long. The light helps, and the light hides. Low sun reveals faint mounds that high sun erases. A single windstorm can uncover a doorway 1 week and bury it the next. The desert is patient. It keeps things, and then, when it chooses, it shows them, and then it covers them again. For tonight, it is enough to picture the slow gold of the late afternoon falling across an endless field of dunes. Somewhere under that warm surface, perhaps, a stone wall stands in the cool dark, untouched for 1,000 years. Perhaps not. Perhaps there is only sand all the way down. We do not know which dunes hide rooms and which hide nothing at all. The light moves on. The shadows shift, and the desert keeps its long, quiet secret. Deep inside the stone, in places where no light has ever reached, there are living things. They are very small, too small to see with the eye alone, but they are there in their countless trillions, coating the walls of caves with a faint film of life. These are the microbes of the deep, and they live in a way that still puzzles the scientists who study them. On the surface of the earth, almost every living thing depends on the sun. Plants drink in sunlight. Animals eat plants, or eat other animals that ate plants. The whole long chain begins with light. But deep underground, the sun is a stranger. No ray of light has ever touched these walls, and yet life thrives there. So the question is simple and strange. What are these creatures eating? One answer, as far as we can tell, is the stone itself. Some of these microbes appear to draw their energy from rock. They pull tiny bits of iron, sulfur, or manganese from the cave walls and use them in slow chemical reactions. The reactions release a small amount of energy. The microbes use that energy to live, to grow, and to make more of themselves. It is a slow, quiet kind of feeding, a meal measured in atoms. If you could listen closely enough, the sound of this life would be almost nothing. No chewing, no movement, just the faintest hum of chemistry, atoms shifting from one form to another inside a single tiny cell. A cave like this is silent to our ears, but to instruments tuned to the right scale, the walls would whisper. Scientists have a name for life that feeds on rock and chemical energy. They call it chemolithotrophic life. The word is long, but the meaning is plain. Chemo means chemical. Litho means stone. Troph means feeding. Life that feeds on chemicals in stone. It is a way of living that does not need the sun at all. In some caves, you can almost see the work of these microbes. Long, slow drips coat the ceilings in soft, slimy sheets. The locals who first found them called them Stalactites because they hang from the rock like thick threads. They are colonies of microbes, billions strong, clinging together in a soft mass. Each thread drips a tiny drop of acid, slowly eating into the limestone below. These acid drips are part of how some caves grow. The microbes help carve the stone, opening new passages over thousands of years. The cave shapes the microbes, and the microbes shape the cave. It is a slow dance, far too slow for us to watch. The deeper question is older. How long has this been going on? Some researchers wonder if life like this is among the oldest forms of life on Earth. Before there were plants, before there was oxygen in the sky, the early planet was full of warm stone, mineral-rich water, and chemical energy. Life that fed on rock would have been right at home. Some scientists suggest that the first living things may have looked a lot like the microbes we now find in the deepest caves. Others are not so sure. They argue that the first life began in shallow pools at the surface, warmed by the sun, and only later spread underground. The evidence is incomplete. Rocks that old have been crushed, melted, and reshaped many times. The fossils of single cells, if they were ever there, may be lost forever. The question of where life first took hold remains open. What we do know is this. Right now, deep below our feet, in caves we have never entered, in cracks too small for any human to crawl through, microbes are quietly turning stone into life. They live without sun, without plants, without any of the things we usually think of as necessary. They are doing what they have been doing, perhaps, for billions of years. Some researchers have started to listen for them in a different way. They lower sensitive instruments into deep wells and old mine shafts. They measure tiny changes in gases, in heat, in the chemistry of the water. The signals are faint, but they are there. A slow, steady pulse of underground life, breathing in its own quiet way. If you imagine the sound of a cave, you may picture water dripping, a stone falling, a soft echo in the dark. Beneath all of that, below even the silence, there is another sound we cannot quite hear. The hum of trillions of small lives, eating stone, drinking minerals, building themselves out of the bones of the planet. A song the earth has been singing in the dark, longer than any of us have been listening. Mapping a cave is a strange kind of mathematics. On the surface, we have satellites, lasers, and bright sunlight. Underground, we have darkness, twisting stone, and silence. To draw a map of a cave, surveyors must measure each step by hand. They stretch a tape from one point to the next. They measure the angle, the slope, the distance. Then they do it again and again for miles. The numbers slowly build a picture. Each measurement is a small triangle in space. String enough triangles together, and a shape begins to form. A long worm of stone passages, a branching root system, a web of rooms and tunnels hanging in 3 dimensions. Cave maps are some of the most patient mathematics ever done by human hands. A single large cave system can take decades to map, with thousands of stations placed by hundreds of people. The math itself is beautiful. Each survey leg is just a few numbers. A distance, a compass bearing, a vertical angle. Together, these 3 values describe a vector in space, a small arrow pointing from one stake to the next. Add up enough arrows, and you have walked a passage on paper. The longer the cave, the more arrows. The deepest known cave systems contain tens of thousands of these tiny measured arrows, each one placed by someone crouching in mud with a notebook. But here is where the mystery begins. The numbers are never quite perfect. A compass might wobble near iron-rich rock. A tape might sag in a long passage. A reading might be off by a degree. These small errors are invisible at first. They hide inside the math, gently bending the map away from reality. Over a long survey, the errors add up. A passage that should close back on itself may not quite meet. There is a gap, a mismatch. Surveyors call this a loop closure error, and they spend long evenings adjusting the math to spread the error out fairly. This is why we cannot truly say how long any cave is. The longest mapped cave in the world, in Kentucky, has more than 400 miles of surveyed passage. But every year, more passage is added. Side leads, unexplored crawls, rooms that branch off and keep going. The map is always provisional. The math always reaches a little further into the dark. The cave itself may be far larger than the map shows. We simply have not measured it yet. There are deeper mysteries in the numbers. Cave systems often show patterns that feel oddly familiar. The branching of passages can resemble the branching of rivers on the surface. The way tunnels split and rejoin sometimes echoes the way blood vessels split inside a body, or the way lightning forks across a sky. Some researchers have wondered if there is a hidden ratio at work, a quiet rule that water follows when it carves stone. Others think each cave is shaped mostly by local chance, by which crack happened to open first. The question stays open. We do not yet know how much of a cave's shape is law and how much is accident. There is also the question of how much cave we have not yet found. Geologists can estimate, from the amount of limestone in a region, roughly how much rock has dissolved away over millions of years. That dissolved rock had to leave hollow space behind. When they compare that number to the length of mapped cave, the mapped portion is often only a small fraction. The rest is sealed, filled with water, plugged with mud, hidden behind walls too thin to see through and too thick to crawl past. The math suggests vast, unseen rooms exist beneath our feet. We just cannot reach them yet. New tools are beginning to help. Laser scanners can capture a chamber in a few minutes, building a cloud of millions of points. Radio devices can sometimes pierce the rock and find a surveyor's signal from the surface above. Drones with their own lights have flown into pits too deep for any human to climb. Each tool changes the math a little, sharpens the numbers, fills in a few more arrows. But the basic puzzle remains. The earth is honeycombed with passages we have not yet measured, and possibly never will. It is a strange thought to sit with as you drift toward sleep. Beneath every limestone hill, there may be rooms no eye has seen, connected by tunnels no foot has touched. They exist as a kind of mathematical possibility, hinted at by water flow and missing rock. The map is a beautiful, partial drawing of a vast unknown. The numbers reach into the dark, and the dark, so far, keeps most of itself. Water beneath the earth moves in ways we are only beginning to understand. It seeps through cracks too small to see. It pools in chambers no human has ever entered. It flows along paths that took millions of years to carve. And in some places, these hidden rivers stretch much farther than anyone once believed possible. For centuries, people have wondered if the underground waters of the world might be connected in ways we cannot see from the surface. A spring in one valley sometimes shares the same chemistry as a river hundreds of miles away. A dye dropped into a sinkhole can emerge days later in a place no map predicted. The deeper we look, the stranger the patterns become. One of the most curious ideas in modern hydrology is that some aquifers, the great sponges of porous rock that hold groundwater, may span entire regions, crossing borders, and even reaching toward the edges of continents. The Nubian sandstone aquifer beneath North Africa is one such giant. It rests under parts of Egypt, Libya, Sudan, and Chad. Some of the water inside it fell as rain tens of thousands of years ago, when the Sahara was green. That water still moves very slowly through stone that is older than memory. Whether any of these aquifers truly connect across oceans is another matter entirely. The idea sits at the edge of what we can prove. Some researchers have wondered if deep groundwater might travel through fractured rock far beneath the seafloor, linking continental systems in faint, slow trickles. Others think the deep crust is too dense, too sealed, too broken by tectonic seams for any such connection to exist. The question remains genuinely open. What we do know is that Earth's underground waters form a system of extraordinary delicacy. The balance that keeps these rivers flowing depends on conditions so precise that it is almost difficult to believe they exist at all. The rock must be porous enough to let water pass, but solid enough not to collapse. The temperature must stay within a narrow band, or the water freezes or boils away. The pressure must hold steady across thousands of feet of stone. Change any one of these things, and the whole system shifts. Think for a moment about how thin the conditions for liquid water really are. Our planet sits at a distance from the sun that allows water to exist as liquid, solid, and vapor all at once. Move Earth closer, and the oceans boil into the sky. Move it farther, and every drop freezes into stone. The atmosphere holds in just enough warmth and reflects away just enough heat to keep that narrow band stable. And below the surface, the geothermal warmth of the planet's interior keeps the deep waters from freezing solid, even in the coldest regions. Underground rivers depend on all of this. They depend on rain that falls on distant mountains and seeps slowly downward. They depend on the slow grinding of tectonic plates that opens new cracks and closes old ones. They depend on a climate stable enough to keep the cycle turning year after year, century after century. A small shift in any of these forces can drain an aquifer, dry a spring, or silence a cave river that has flowed for ages. In the Yucatan Peninsula of Mexico, a vast network of flooded caves called cenotes weaves beneath the limestone. Divers have mapped hundreds of miles of these passages, and they still find new chambers each year. The water here is famously layered, fresh on top, salt below, with a faint, shimmering boundary between them. That balance is held in place by the careful pressure of the sea pushing in from one side and rainwater pressing down from above. If sea levels rise, the salt layer climbs. If rainfall drops, the fresh layer thins. The cave river system rests on a knife's edge. There is something quietly humbling about all of this. The hidden waters of the earth move in patterns we have only partly traced. They cross beneath deserts, beneath cities, beneath the floors of seas. They follow paths older than any human language. And they keep flowing only because so many things, large and small, happen to line up just right. If the planet warmed too quickly, some of these slow rivers would lose the rain that feeds them. If the crust shifted in the wrong way, others would drain into chambers we have never seen. The whole network is held together by conditions that took billions of years to settle into place. And whether any of these waters truly reach from one continent to another, threading through the deep rock in some hidden, ancient circuit, is a question the dark below has not yet answered. Deep inside a cave, the air holds a kind of silence that feels almost solid. It is not the silence of a quiet room. It is older than that, heavier. The silence of a place where wind rarely reaches and where sound, when it does come, travels in unexpected ways. Cavers have written about this for as long as people have explored caves. They describe halls where a whisper carries for hundreds of feet, and chambers where a shout seems to vanish into the walls. The reasons are partly understood. The full picture is not. Sound moves through caves in ways that still surprise the people who study them. A long, narrow passage can act like a pipe, pushing a voice forward in a strange, thin line. A round chamber can bounce sound from wall to wall, layering echoes until they blur into a low hum. Wet stone absorbs sound. Dry stone reflects it. Crystals scatter it in tiny, bright pieces. Each cave has its own acoustic shape, and no two are quite alike. Some researchers wonder if early humans chose certain chambers for painting because of how those chambers sounded. The cave walls with the oldest art often sit in spots with the richest echoes. Whether this is meaningful or only a coincidence remains an open question. There are also sounds inside caves that no human voice makes. Drip echoes are the most common. A single drop of water falling from a high ceiling into a still pool can produce a clear, bell-like tone that repeats every few seconds. In a large chamber, dozens of drips overlap into something that sounds almost like quiet music. Why some pools ring and others stay dull is partly about depth and partly about the shape of the basin beneath. The exact recipe is still being studied. Then there are the deeper sounds. Cavers in long passages sometimes report a low rumble that has no clear source. It is not loud. It sits at the edge of hearing, more felt than heard, a soft vibration in the chest. Some of these rumbles trace back to underground rivers, moving through hidden channels far below. Others may come from air pressure shifts between the cave and the surface, the slow breathing of the mountain itself. A few have never been matched to any known source. The recordings exist. The explanations do not, at least not yet. Caves can also produce sudden sharp sounds. A piece of flowstone, after thousands of years of slow growth, may crack as it cools, or as the rock beneath shifts by the width of a hair. The crack can echo through a chamber like a soft gunshot, then fall back into silence. Researchers have begun placing microphones in deep caves to listen for these events over months and years. The recordings reveal a quiet, constant activity that nobody hears in the moment. The stone is moving. The stone is settling. The stone is, in its slow way, alive with small adjustments. How often these adjustments happen and what triggers them is still being mapped. Some of the strangest sound reports come from caves with large bodies of standing water. In certain chambers, when the air pressure outside changes, the water can pulse gently, sending faint ripples across its surface. Those ripples make their own soft sound, almost like breathing. There are caves where, on certain still days, the whole chamber seems to hum at a frequency just below comfortable hearing. One idea is that the cave is acting like a giant musical instrument, with the air inside vibrating at a natural pitch set by the chamber's shape. Another idea is that distant earth movements, far too small to feel, are passing through the rock and setting the air inside trembling. Both ideas may be partly right. The full answer is not in yet. What makes all of this so wonderful is that we are only at the beginning of listening. For most of human history, caves were entered with torches and voices, and the sounds we made drowned out the sounds the cave was making on its own. Quiet microphones, left alone in the dark for long stretches of time, are new. The data is still coming in. Whole categories of underground sound may exist that nobody has named yet. So the deep stone halls of the world continue their slow, soft music mostly without listeners. A drop falls. An echo rolls down a passage. A piece of crystal settles by a hair's width. Somewhere, a low hum rises and falls with a rhythm no one fully understands. The caves are speaking in their patient way, and we are only beginning to learn the shape of the language. Caves, it turns out, may not belong to Earth alone. For most of human history, we pictured caves as a feature of our own world, carved by our own rain and our own rivers. But as we have begun to look outward, we have started to find dark openings on other worlds too. Round shadows on the surface of the moon, pits in the dust of Mars, strange skylights where the ground seems to drop away into nothing. We do not yet know what lies inside any of them. The question of what they hold is one of the quietest, most patient mysteries in all of science. The moon, our closest neighbor, has openings that may lead into long lava tubes. These would be hollow tunnels left behind when molten rock once flowed beneath the surface and then drained away. On Earth, similar tubes exist in places like Hawaii and Iceland, and they can stretch for miles. On the moon, where gravity is weaker, some researchers wonder if lunar lava tubes could be enormous, perhaps wide enough to hold whole cities. We see only the shadowy mouths from orbit. The interiors remain dark, untouched, and silent in a way that is hard to imagine. Mars carries its own dark doorways. Cameras circling the red planet have spotted small black pits along the slopes of old volcanoes. They look like wells punched straight down into the rust-colored ground. Some appear to be skylights into ancient lava tubes, just like the ones on the moon. Others may be sinkholes where the surface has fallen into hidden voids. No rover has ever entered one. No probe has ever sent back a picture of the inside. We know they are there. We do not know what fills them. The reason this matters reaches beyond curiosity. Underground spaces are sheltered places. They shield whatever lies inside from radiation, from extreme cold and heat, from the constant wind of dust and tiny meteorites. On a world like Mars, the surface is harsh, but a deep tunnel might hold a steadier climate. Ancient ice frozen in cracks, even pockets of chemistry that that could not survive above. One theory is that if simple life ever existed on Mars, it may still linger in these hidden chambers. Another theory is that the caves are sterile and have always been. Both possibilities remain open. There are stranger places to wonder about as well. The icy moons of the outer planets, distant cousins of Earth, may have their own kinds of caves. Beneath thick shells of ice, some of these moons appear to hold vast oceans of liquid water. Where ice meets water, melt channels and frozen caverns may form. We have only the faintest hints of these worlds, gathered from spacecraft that passed by long ago. Whether true caves exist there, and whether anything stirs inside them, is a question we cannot yet answer. Closer to home, the future of Earth's own caves stretches across timescales that bend the mind. In 1,000,000 years, many of the caves we know today will still exist, slowly growing larger as water continues its patient work. In 100,000,000 years, continents will have drifted into new shapes, and new mountain ranges will have risen. Fresh caves will form inside them, while older caves may be lifted, tilted, or crushed back into solid rock. The hollow places of the earth are not permanent. They are part of a long, slow breathing of stone. Further still, in 1,000,000,000 years or more, the sun itself will grow brighter and hotter. Oceans may begin to thin and fade. The water that carves caves today may become scarce. Yet even then, lava tubes will still form wherever volcanoes rise, and ice caves may appear in whatever cold corners remain. The underground will keep finding ways to exist, even as the surface changes beyond recognition. For now, the question of what waits inside the dark mouths on other worlds drifts gently in the background of human science. Plans exist on paper for small robots that might one day rappel into a lunar pit or roll cautiously into a Martian skylight. Whether those missions ever happen and what they would find, no one can say. Each pit on each distant surface holds its own quiet secret. It is a soft thing to think about as you rest. Somewhere on a world far from this one, a wide stone chamber sits in perfect darkness, untouched for billions of years. No footstep has ever fallen there. No light has ever reached it. It waits why Earth's deepest caves waited before we found them, patient and unhurried, holding whatever it holds, while the slow turning of the universe continues on, becoming always something new. For as long as people have told stories, they have told stories about what lies beneath. Almost every culture on Earth, separated by oceans and mountains and centuries, has imagined a world under the ground. The names change. The shape of the story shifts. But the pattern is strange in how often it repeats. Caves, it seems, have always lived inside the human mind as much as they have lived inside the planet. In ancient Greece, the dead were said to cross a dark river into a kingdom of shadow. In old Norse tales, vast halls stretched below the roots of a great tree. In the highlands of Mesoamerica, certain caves were treated as doorways, places where the living world thinned and the other world pressed close. In parts of Asia, dragons were said to sleep in stone chambers deep below the hills. In the deserts of North Africa, travelers spoke of cities hidden beneath the sand. The details are different. The instinct is the same. Why do so many cultures, with no contact between them, place a hidden world below the soil? One idea is simple and physical. Our ancestors saw caves. They saw springs rising from stone. They saw sinkholes open without warning. They felt cool air drifting up from cracks in the rock on hot summer days. The ground was clearly not solid. Something was down there. The mind, hungry to explain, filled the dark with meaning. Another idea reaches deeper. Some researchers wonder whether early humans actually used caves as sacred spaces, and whether the memory of those rituals became woven into myth. The painted chambers of Europe, the smoke-darkened ceilings of Africa, the burial alcoves of the Levant, all of them suggest that caves were not just shelters. They were places set apart, places where the boundary between the living and the lost felt thin. If our distant ancestors gathered in such places for tens of thousands of years, perhaps the feeling of those gatherings survived long after the rituals themselves were forgotten. A third possibility is even quieter. Caves change a person. Step into one and the senses shift. Sound deadens, then echoes in strange ways. Light fades to nothing, temperature steadies, the body slows. Some who spend long hours underground describe a feeling close to dreaming. It is not hard to imagine that early people, sitting in such a place by torchlight, felt themselves standing at the edge of something else. The story of an underworld may simply be the story of what the human mind does in the dark. None of these ideas cancel the others. They may all be true at once. The mystery is not whether caves shaped our myths, but how deeply and how early, and in what ways the shaping still continues. We may speak of the underworld now in metaphor. We may smile at the old stories. But when a person steps into a true cave for the first time, and the light of the surface vanishes behind them, something old still stirs. There is a wider view to hold here as well. The stone around those ancient chambers was not always stone. The calcium that built the limestone walls began as the shells of tiny sea creatures, drifting down through warm, shallow oceans hundreds of millions of years ago. Those creatures took their calcium from the water. The water took it from older rock. The older rock took it from older rock still. And far back, before Earth even formed, the calcium itself was forged inside dying stars and scattered across the dark. The walls of every cave are, in a quiet sense, made of starlight. The bones of the people who painted those walls were made of the same material. The water that carved the passages came from comets and from the slow breath of the young planet. The air that drifts through the chambers carries atoms that have been breathed by forests, by oceans, by creatures long extinct. Nothing in a cave is truly separate from anything else. Perhaps that is why the underworld lives so deeply in human memory. It is not only a place below our feet. It is a place that holds the long story of the earth itself, written in stone, in water, in silence. To stand in a cave is to stand inside deep time. To imagine an underworld is, in a way, to imagine the whole patient history of the planet pressing up against the soles of one's shoes. The legends may be old. The stone is older. The atoms are older still. And the question of what lies below us in every sense has been with us from the beginning and is with us now in this quiet hour as the world settles toward sleep. come to the end of our slow walk through the hidden world beneath our feet. We have wandered together through chambers no sunlight has ever touched. We have listened in our minds to water dripping in long, patient rhythms. We have stood beside cave pearls and frozen waterfalls of stone, beside pale fish with no eyes, beside walls painted by hands that vanished thousands of years ago. And still, the deepest part of the story is this: we do not know how much of it remains. The maps we have drawn of the underground are small. The passages we have walked are few. Beneath the forests, beneath the deserts, beneath the seafloor itself, there are likely caves no human has ever entered. Some may hold water that has not seen daylight in millions of years. Some may hold tiny living things that feed on stone quietly in the dark. Some may hold air that was breathed by no lung ever. Whole rooms may exist beneath your town tonight, sealed off behind a curtain of rock, waiting in perfect stillness. We may find them one day. We may not. The earth keeps its quiet rooms well. Even the caves we have entered still hold open questions. We are not sure how some of the largest crystal chambers grew. We are not sure how deep certain flooded systems truly go. We are not sure whether some underground rivers connect to others far away, beneath mountains and seas. We are not sure what made certain ancient footprints, or who painted certain walls, or why some chambers seem to hum softly when the wind shifts on the surface above. Each of these is a thread that has not yet been followed to its end. And there are larger questions, too. Whether caves on other worlds, beneath the red dust of Mars, or beneath the ice of distant moons, might shelter something alive. Whether the legends of underworlds in our oldest stories carry some faint memory of real shelters our ancestors once used. Whether the slow, patient work of water on stone is happening right now in places we will never see. The honest answer in almost every case is that we do not yet know. That is a gentle thing to rest with. Not every question needs to be closed before sleep. Some questions are better as companions than as answers. They keep the world soft at the edges. They remind us that the planet we live on is older, deeper, and stranger than any single mind can hold. Picture, for a moment, the Earth from far away, a quiet blue sphere turning slowly in the dark. Oceans resting under moonlight. Continents wrapped in cloud. Forests breathing out their cool night air. And under all of it, threaded through the stone like veins of silence, the caves, dark rooms, dripping water, pale creatures drifting through pools that have never known a ripple from above, crystals growing one atom at a time, air moving in and out of hidden mouths in the hillsides, the slow breath of the planet itself. All of it is there. All of it is real. All of it is going on without needing to be watched. You are held by a world that keeps its own quiet wonders. You do not have to solve them tonight. You do not have to remember every chamber, every theory, every name. The mystery is allowed to remain. The dark rooms are allowed to stay dark a little longer. The water is allowed to keep dripping, slow and steady, in places no one will ever see. Let your breath grow soft. Let your shoulders settle. Imagine yourself standing at the mouth of a cave at dusk, looking in, not afraid, simply curious. The air is cool. The stone is old. Somewhere far below, a single drop of water falls and lands in a still pool, and the small sound of it travels up through the chambers and out to where you stand. The earth is breathing. You are breathing. There is nothing more you need to do. We may learn what lies in the deepest passages within our lifetime. We may not. The planet has been keeping these rooms for a very long time, and it is in no hurry to show them all at once. For tonight, it is enough to have wondered. It is enough to know that the dark is not empty, only quiet. It is enough to drift toward sleep with one soft question still glowing in your mind, like a small lantern set down at the edge of a long, patient tunnel. Subscribe for a brand new Earth topic every night. One tap, and something wonderful is waiting for you tomorrow. Sweet dreams.